So I will start by talking a little bit about the survey that we did and what we found from your feedback about the submicron and ultrafine particles. Then we will dive a little bit in the literature in order to understand what the scientific community says about the submicron, again, ultrafines. And finally, I have some questions for discussion. And as we are few people today, we will have the chance to get to know each other a little bit better. Kevin, do you mind muting your microphone, please? Thank you. Okay, so this is what is happening nowadays with particulate matter. This is what we can see, and this is what is regulated. PM 2.5 is well measured from many instruments and well regulated by many bodies out there. But unfortunately, there are other hazards in the space of particulate matter, the submicron and ultrafine particles. The other day on social media, I posted this picture of the analogy between PM 2.5 and ultrafines, and we have one fine particle of 2.5 in diameter, aerodynamic diameter, which equals to 10 micrograms per cubic meter in mass. And then we have 2.4 million ultrafine particles of 20 nanometers in size. So we can understand now that we have a problem in our hands that we will have to solve. And then I find another image out there that explains a little bit better that depending the different source of the PM, we will have a different surface area and particle number, even though we will have the same mass. So here, for example, in the screen, we can see that we have different particles from different sources: traffic, urban background, secondary aerosols, biomass, and dust from Sahara Desert. They all give us the same value of 12 micrograms per cubic meter, but then they have different surface area, fewer or more, and again, different particle number, depending their composition. Let's begin with submicron particles. This is the results from the survey. Basically, 47% of the respondents say that we start to implementing measurements with monitoring solutions that they can measure at specific sizes. And another 47% feels that it is unclear, but more research is needed. So in total, we have like something like 94% of the people that agree that we have to investigate further. The health risk based on the survey, we had like a 95% agreement that submicron particles is a superior indicator of health impact. And at the same time, on the technical aspect, 72% of the experts state that the current technology is not yet sufficient cost effective. I did a little bit of research to see the prices of submicron particle counters, and they start from 150 and they can go up to 1,500 euros only for the sensor component, so the electronic component, that complies with a specific ISO specification that consists in having accuracy in the measurements of those particles. And then in the question, what is the best measurement way or recommended value metric for submicron particles, 58% they say that particles per cubic centimeter is the right way to measure those particles. Some they suggested like micrograms or nanograms per cubic meter, but I didn't find any support of it in the literature. So this is the overview from the literature. So many papers say that submicron particles, they go deeper, the human body, and they also have a stronger association than to PM 2.5 with lung cancer, cardiovascular diseases, and childhood pneumonia. Also, something else that it was very interesting for me to read was the finding highlight that PM1 is primarily a byproduct of human activity, specifically fossil fuel combustion rather than natural processes. And then the main composition of the particles in some studies, they find like 47% are sulfates, 22% nitrates, 12% black carbon, and 8% of ammonium. Oh, sorry, black carbon 8% and ammonium at 7%. Mainly, it is an anthropogenic nature. So for this reason, some papers say that it's more targetable for regulation than PM2.5. And they were able to find also trace metal, especially from vehicle emitted metals, from brakes especially, when they analyze those specific submicron particles. That they are associated with cancer risk and so on. Indoors now, something that the scientists have observed is that unoccupied indoor environments often act as a sink for PM1, with concentration typically being 50% lower than outdoors. So basically, particles rest and deposit to surfaces. Then in another paper, they found that 70% of the outdoor PM1 particles, they can penetrate and they can infiltrate inside buildings. Remember now here that even HEPA filters, they suffer with something that's called the most penetrating particle size at 0.3 microns. So that allows those particles to infiltrate buildings, even if we have filtration systems in place. And then something else that happened when outdoor air enters the warm indoor environments, some micron ammonium nitrate particles, often volatile, so they turn back into gas, and started reducing the indoor particle mass. Research regarding some microparticles in indoor environment indicates that while buildings often act as a protective shield against outdoor pollution, the indoor air undergoes significant chemical cleanses once ambient air is infiltrated. So as you understand, it's quite complex. Then I tried to find what is the preferable unit of measurement for submicron particles out there. And several papers argued that the mass concentration alone is insufficient metric. So some of them, they were talking again about particles per cubic centimeter. Then some other, they are talking about lung deposit surface area, or DSA, and some others oxidative potential, which is a toxicologically relevant metric. The problem with lung deposit and oxidative potential is that they require more information from the measurement that we are taking. So they are not only counting the particles of specific grains, but they are also need the information of the size of the particle, and in some cases the composition of the particle as well, which can complicate the measurement if we would like to implement something in the indoor space. Especially as those instruments that are able to do that, they are quite heavy, noisy, and expensive. So I was also trying to find any values that they can help us understand what are the ranges of safety, right? Now, inside clean rooms, which is the only thing that I could find, this is what is proposed by the ISO and also the US federal standard when it comes to counting the particles and having specific protection for the equipment inside the different clean rooms, right? So we would find for 0.3 and 0.5 micron in size particles that they say that they shouldn't surpass those specific limits. So I was thinking, what if we take the same logic and we apply it for the indoor environments like apartments and so on? Here I have converted the values to particles per cubic centimeters in order to make them a little bit easier for us to understand. And then I just focused on the last two ISO classifications, or as the US standard says, RUMEA, right? So the ISO 9, for example, extrapolating the information from the similar logic the ISO committee has done for the different tiers. Those are the values that they are proposing, more or less, right? Like for 0.5, 3.52 particles per cubic centimeter, and for ISO 9, 35.2. and something similar for 0.3. I did some testing in order to see how those numbers can relate with the reality. So again, those are unpublished measurements in an office with a HEPA HVAC system in place. You will see that for 0.3, I measured 8.4 particles per cubic centimeter, which that equals to 0.73 microns per cubic meter. And for 0.5, I measure 1.1 particles per cubic centimeter, and then the equivalent. And again, I did some measurements in Barcelona, background seaside. So probably there we will have measured some sea salt or sea spray. But I don't think that was the case. For 0.3, we had 45.8 particles per cubic centimeters, and for 0.5, 5.4 particles per cubic centimeters. Again, when we are talking about 0.3 or 0.5, instruments are not able to measure just one specific size of particles, so they group them under that number. So for 0.3, we talk about particles between 0.3 and 0.49 micron in size. And for 0.5, 0.5 to 0.99 microns. Okay, so that's the findings for submicrons. Let's go to ultrafines. From the survey, more than half of the group consider ultrafine particles more important, and they emphasizes that the mass-based sensors like PM2.5 often fail to detect major spikes. And that's true because, as we can see from this sentence, again, we highlight that those sensors cannot measure anything below 300 nanometer or 0.3 micron. Technologically speaking, currently it's very difficult to measure those particles in the indoor environment. Equipments are expensive. They range for 5 to 15 or even more €1,000. So we couldn't invest in something like, let's say, continuous monitoring with that kind of technology, but rather than spot measurements or evaluations during a specific period of time. And finally, the predominant recommendation was again particles per cubic centimeters, but some other experts recommended the lung deposited surface area as well. From the literature, again, we found that ultrafines have even more severe inflammation to the lungs and other organs because they can bypass the alveolar capillary barrier, and they can distribute all around human organs. And for these reasons, we have more cases for cardiovascular diseases, hypertension, diabetes, low birth rate, and so on. And even the cancer risk is higher as well. Indoors now, domestic activities can produce ultrafines as well, specifically cooking, but also infiltrations of particles from outside, like from vehicle emissions. One study highlighted very clearly that hair dryers, for some reason, lead to very highest levels of indoor exposure. And also like toasting breads, frying, burning candles, and so on, and even laser printers, they can produce ultrafine particles. In the hospital environment, in operating rooms, smaller ultrafine particles exhibit lower exchange rates due to the stronger Brownian motion, making them more difficult to remove than larger particles, according to one paper. And again, here, the researchers argue about the fact that we cannot use mass concentration in any case for ultrafine particles. They recommend, in many cases, the particles per cubic centimeter. Again, the lung deposit was also mentioned in some other papers. And some other scientists clearly say that instead of proposing a single safety threshold, why current standards they were discussing why current standards were insufficient, and suggest technical improvements for future regulation. Regulating PM2.5 mass may not significantly reduce ultrafine levels. And keep in mind that in automotive industry, they are breaking particles smaller in order to, surpass these PM 2.5 levels. Although now here in Europe, we do have regulations that they must measure the ultrafines from the exhaust of vehicles just to make sure. But that's not the case everywhere around the globe. And some other papers, they say that in the absence of regulatory limits, some researchers recommend that background concentrations, levels measured just before an active start, should be systematically reported as a reference value to make measurements more meaningful. That's it. That's something that we do for indoor air quality, specifically when we measure mold particles, right, or spore particles, and some of the specifications out there, they say go outside, measure the air, and then go inside and measure and see what's the difference between those two environments. I also try to see if there is any recommendation out there regarding limits and different concentrations of ultrafine particles. So according to some papers I found, for rural background, they say that they are approximately 2,600 particles per cubic centimeter. The global urban mean is around 10,000 particles per cubic centimeter. A roadside hotspot can have concentrations up to 48,000 particles per cubic centimeters, which is like 10-fold higher than the background level. And indoors, when events happen, like what I have mentioned earlier, concentrations can go up to 2.3 million particles per cubic centimeters. Now, WHO has some good practice recommendations, which are a little bit problematic, especially when you provide it with both 24 and 1 hour mean values, as they can give a little bit of mixed understanding of what's happening. So here is an example from some measurements that I took inside my house a few weeks ago during a 24-hour period and 1 hour mean. So the average value for 24 hours was 2,900 particles per cubic centimeter, which according to WHO is above low threshold. And then it is well below high risk. And then the 1 hour mean for a specific period that I decided to go with, it was extremely low, right? So there is a mixed communication here, which I think creates a problem on how we can, communicate. It is better if we have like a range rather than have a thread tier that can offset us completely from understanding. Now, the problem with indoor air quality now is that it's very difficult to measure during 24 hours what is happening in a real environment, because instruments are noisy and occupants wouldn't like something like that happening in the real situation. Again, some unpublished data that I took in order to correlate a little bit PM 2.5 and ultrafines. Indoors, I had a very strong correlation. I think the reason was because, first of all, it was unoccupied, the specific environment, and we didn't have any specific source of pollution happening rather than particles staying alive for a period of time inside. Maybe some infiltration as well, but more or less that was the result that I got. Outdoors, though, we had very weak correlation between PM 2.5, and that's very normal because now we have the real complexity of atmospheric conditions and sources from different sources and so on. Here, I would like to summarize a little bit what we find from the research literature and also the survey. Size definition, when we are talking of submicron particles, we have two tiers, 0.5 and 0.3, with representative ranges. And for ultrafines, most of the research out there, they say that we should measure from 100 to 10 nanometers. Some standards or some regulations out there, they have set a limit to 23 nanometer, but according to research, it's not appropriate because between 23 and 10 nanometers, we can have even 300% higher concentration of ultrafine particles. You know that like health risks for submicrons and for ultrafines are higher than PM2.5. Major sources, again, anthropogenic sources for both categories of particles. From the research, from the survey that we did, 94% agree that we have to investigate it more what is happening with the submicron particles inside buildings. And also at the same time, I think it's more easy, economically speaking. And on the other hand, for ultrafines, 53% considers that we have to consider monitoring indoor ultrafines indoors. But almost 60% of the experts say that it's very not cost effective to do it in a continuous way. And the preferred metric for submicron is cubic centimeter per cubic centimeter, particles per cubic centimeter. And for ultrafines, the same, but also lung deposit surface area, which is easy to do, right? It's a little bit more complicated to calculate it, but it's easy. But then we have to set different standards for those different metrics, right? Like what is acceptable as a microgram per cubic centimeter. It's quite complicated as well. So now some time for discussion. I have prepared some questions, but feel free to raise your hand or speak or write a question on the chat about any questions that you have. So the first question that I would like to discuss is, do the people in this call today agree that measuring submicron particles is a superior indicator for health impact, and we should start getting more measurements as it is, let's say, more easy nowadays to measure those particles? Don't be shy. If you cannot speak, because in some cases you are in some kind of place with other people, feel free to write a comment. I will continue with the questions, but feel free to interrupt me anytime. Again, I think the preferable metric should be particles per cubic centimeter for submicron particles. I hope everyone agrees. You can also use the interactions down with a thumbs up or, I don't know, clap in order to give me a little bit of feedback. And then when it comes to the size of the particles, I get that those are the ranges of the particles when we are talking about 0.3 or 0.5. I hope you agree and you haven't found something different out there, or you have worked with something different, because you never know. And when it comes to the limit of, which is the most important question for me, when it comes to the limit of range of acceptable particle number, what we should recommend to the public? I think we should start taking measurements in different environments and see what we can recommend based on the measurements and comparing against each other. But I need your support on that. So you will have to provide us with that kind of information at some point.
Hello, everyone. I am Begoña Pérez Moneo. I am a pediatrician here in Spain. And I nowadays I am studying particles inside schools. And I made a review of the literature about children, and there are a lot of articles about PM 2.5 or 10, but very few about micro or ultrafine. So I think it's very important to make more investigation about this. And obviously we have to measure these particles, because if we can't measure them, we can't do any investigation. And also, I think that the results about children's health, they are also very important. So I think that we have to make more research about this. But it's difficult. It's difficult because some of the health events happens very late in life. So maybe we have to make measurements of other things, oxygen radicals or metabolomics about the children.
Mm-hmm. Thank you so much for your addition. I see someone has raised his hand. TC Hsiao.
Hello. Hi. My name is Tachi. I'm from Taiwan. So, for the first question or the topic, I do think we need to measure the particle with a size less than like 1 micron. We call it submicron, or even the particle less than 100 nanometers. I think we're starting to discuss about that just because even the PM2.5 mass concentration going down and down, but the health or outcome, or we do not see a comparable increase on those improvement. I mean, reduce the relate disease or from the epidemiology results. I think that is the starting point and linked to some health risk. So that is why we're starting to search the other index. For example, now you propose you present during the presentation LDSA or OP. I think those are two different perspectives. One from more physics, that is we discussed in my paper, and the other is more related to the chemical composition, that is OP. We don't, because both are quite expensive in terms of measurement. I mean, if you want to measure the particle size distribution to understand their long deposit fraction or calculate the dosage, you have in order to do that, you have to have the whole size distribution. But to do that is quite expensive. You must have some like SMPS, or it's too expensive. So that is why people starting to think about like LDSA, because that combine the particle size information and also the long deposit fraction. But that is purely physics. So that is why we start to see a lot of people try the other index called OP, stated potential. We also studied that a lot. That kind of compensate the other portion of the information. Like they do not need to understand the detailed chemical composition, but just use another index, another process, another surrogate to index the toxicity. So that jump to the second question. I don't think the particle number is a good metric, actually, because it doesn't tell us too much about like both, I mean, physics, and also it makes a lot, or chemistry. It makes a lot of information. So I don't think that is a good metric. That is from my point of view, and I give you the rationale and why I don't agree with that one. The third issues, I do not quite understand that one, because normally the subsecondary, that means the particle less than these numbers. So when I see the PM.3, I always think about the particle number less than 0.3 micrometer, not the particle range between 0.3 and 0.49. So that is confusing for me. And the same reason for the PM 0.5, I would assume the particle number less than 0.5 micrometer, not between 0.5 and 0.99 micrometer. So I do not agree that one, because quite confusing, is not follow the same logic we normally use for like a PM 2.5 or PM 1.0, those things. And for the force issues, I don't think we currently have the knowledge to really have some acceptable particle number, because we even don't know the number concentration is a good index or matrix or not. So do we need really to discuss about that? I don't know. And in order to have some idea about that, we have to do the measurement first. I know the European country already have some network, have a lot of data, so a lot of API study, I think, ongoing to try to get the number. So I guess later on, I hope to hear some of the other people's opinion on that one, but so far I don't have some recommend number for that one. And something else, again, my suggestion, just like combine the LDSN and OP. One represent the physics, the other represent more like chemical perspective, and combine these two to like a constraint, not just only use rely on either one only, because both have a different kind of importance on different perspectives. So and we need to do the measurement, and the difficulty is non-uniform because those are particles is quite non-uniform in terms of space and time. So I think that is the difficulty, and that is my comment or my suggestion or my opinion. Thanks.
Thank you for your input. To add a little bit on what you said, I think the reason most of the people agree with particles per cubic centimeter is not because it's the right number, let's say, but it is easier to measure. It doesn't require other things, like it doesn't require the size of the particle, it doesn't require the composition of the particle, and so on. So it gives you an idea, a little bit better idea, let's say, than mass. And when it comes to your comment about the confusion with PN 0.3, PN 2.5, those numbers are coming from the ISO certificate or the ISO standard when it comes to how they calculate and how they calibrate the sensors to those specific sizes of particles. So basically, it is extrapolated from there. And yes, when you say PM1, you're referring to 1 micron and less, or PM 2.5, 0.5 and less. And this is the reason I wrote PN and not PM, because I wanted to make it clearly that this is the number and this is the range according to the standard that I was able to find.
And another issue I would like to bring up is like you also mentioned the definition of the particle size. I mean the range down to like a 23 nanometer or 10 nanometer. I think 23 is the standard we use for like the exhaust, the emission originally, but recently they also lowered down to the diesel engine exhaust emission standards. I think recently they also lowered the limit down to like 10 nanometer to align the standard. And but even 10 nanometer is an issue. I mean, right now the problem is what is the lower end, not just only the upper end, because they will dramatically influence what is the limit of the range of the acceptable particle numbers, because they change a lot. I mean, down lower like 5 nanometer or 3 nanometer change the number a lot. You know, the particle less than 10 nanometer could also occupy or contribute like more than thousands, even more, to the particle number per cubic meter. I expect even more, 10,000 could be sometimes. Yeah.
Thank you. All right, so I think when it comes to submicron particles, again, more research is needed. So I would like to invite all of you, if you have the capabilities, I mean, instrument capabilities, to start taking measurements and sharing those numbers with us in order to understand. I know some of you already do. Like, for example, Maria del Mar, you hear me, you told me that you are taking some measurements inside different school environments. So please make that kind of information available to us in order to understand a little bit better the different levels around different indoor environments. All right, and similarly as for submicrons, we have for ultrafines, similar questions. I think we already discussed them, but again, if you have more comments about them, feel free to raise your hand or speak directly. It's not like we are many people here in this call. Yes, Maria del Mar, please.
Yeah, thank you very much, Soterios. I'm Mar Barbero. I come from Madrid. I'm architect. About these questions. Firstly, when I wanted to say, as Begoña said before, that the ultrafine particles are very important to measure because there is a very few amount of literature. We, as you mentioned, Soterios, we were measuring these ultrafine particles for 3 years, and in different schools and different surroundings, and we found that it's very difficult to find a pattern about the performance of the different particles. We found a lot of amount when we were measuring the particles for centimeters, cubic centimeters, and in fact we found from very huge amount of particles, so very few to very low amount. And as I mentioned before, we could not find up to now a clear pattern to justify the performance. About the correlation with that you mentioned before, Soterios, with the PM 2.5, we in fact found that there is no correlation between these ultrafine particles and the other particles, and perhaps because there is a huge variability about the factors that influence this amount of particles. For example, I remember that we were measuring one day in one school that they were cleaning with air, and the particles were crazy, completely crazy, the amount. But yeah, in any case, we will try to find some measurement to share with you. But up to now, we are still trying to evaluate the results. And about the way to measure, I think that you change the slide about the way to measure the 0.3 and the 0.5. In fact, it is very important, I think, to fix one method to measure, because up to now, what I know with the equipment that we were using is that there is nothing, there is no a common criteria to measure them. Some of them, for example, we found that some of them they measure, or they say that they measure the ultrafine, the particles under the 0.3, or they measure the particles that they go from 0.3 till the next amount, or till the next particle. For example, we have a device that we measure 0.3, and the next particle is is 1. So the company, they told us that they were measuring the particles between 0.3 and the 1. That it is very huge. So I think it's important to try to fix some homogeneous criteria, and I don't know if it is. It is. I agree with Hiesao that perhaps it's a bit confusing about the 0.3, 0.3, and 0.49 that you mentioned before. But in any case, it's important. Perhaps it should be set 0.3 line,
yes.
plus 0.49 or 0.3 till 1 or whatever, no? But to specify very clearly what you are measuring, no? Because there is a lot of confusion about this, no? And I think that's all. Thank you.
Thank you. Yes, I think you are right. And now that I'm thinking, I think it has to do with what kind of instruments do you use. Because if you're using like SMPSs or ultrafine particle instruments, they tend to have the logic Professor Isiao mentioned. But then when it comes to the particle counters that the one you have, they have a different logic and they measure bins between 0.3 and 0.49, and for 0.5 they measure 0.5 to 0.99. So yes, maybe we have to be more clear in the way we communicate, and this is the reason I wanted to present it that way here in this meeting today, in order to make it clear, or we have to decide it and later on communicate it with the public as well about this is what we are considering when we are talking about those specific particle sizes. But also we have to take into account what instruments out there they can do, because SMPSs, correct me if I'm wrong, they cannot measure above 300 nanometers, right? So they couldn't see that range of particles, if I'm not mistaken. And again, I'm sure there is an instrument that maybe can do that, but from those that I have used, they measure up to 300 nanometer.
No, I think SMPS can measure particle down to and up to like a wide range. Just depends on your the
brand,
DMA or
yes.
and the CPC you use. Normally, the limitation for the lower detection limit is due to the CPC, and upper part is due to the particle loss. Actually, it's not the capability of this instrument. So actually, you can measure particle if you have a long enough DMA. For the particle lab, actually, they have like a 2 meter long DMA that is extremely large DMA. You can measure particle up to like a 2 micron or 5 micrometer. That is possible, but that also creates some difficulty on inversion. But that is not the point. The point is like if I would like to say like SMPS technique can measure particle of like a less than 1 micrometer quite well. Or in general, the TSI1 can measure particle from lower to 2 nanometer up to like 700 nanometer. There, that is the fair claim for the SMPS technique or DMPS.
Again, I took into consideration here the affordability of the instruments, and that specific range here that complies with that specific ISO standard allows some of the companies out there to have instruments of less expense, and so it's going to be more readily available for the researchers to buy and use and measure. Like, for example, the example of Maria del Mar, that they have an instrument of that caliber that can measure a specific range of particles, complying with that specific ISO regulation or standard, in order to provide you with the measurements in an accurate way. And we have to keep in mind that we have to make this connection to our heads, that what kind of technology do we have available in order to measure those different sizes of particles and the purpose of it, right? In many cases, I will say, again, this is my position, that in the indoor space, the reason that I really like submicrons is because, technologically speaking, we do have those solutions to measure them easily without breaking the bank, and having an accurate number around it, because we do have that specific ISO certificate around it. And this is not the case, for example, with PM2.5, where you always have to do correlations and collocations with reference instruments in order to determine how accurate are they, and from there to continue your research. Those instruments, as they comply already to a standard, to an existing standard, you don't have to do that. Like you can feel comfortable that the values you are getting are accurate. Okay. Any other comments? I see here on the chat box, we have a comment from Valeria about, can we suggest some reliable sensors for these measurements? We usually do indoor monitoring, and we can always consider to purchase and add sensors. Valeria, I will reach out with some recommendations about product. I don't want to start naming here companies. Yes, and I will assume you are talking about submicron particles or ultrafine particles. If you can give me that specification.
I mean, we can do both potentially. We always have potential to buy equipment through our projects.
Mm-hmm.
So yeah, one of the two or both would be good to know.
Perfect. Yeah, absolutely. All right. So unless someone else has any other comment, I will say, and I will close with this sentence. When it comes to submicron particles, we have to accumulate more information from research and your measurements out there. Provide that kind of information with us. It's very important in order to get an understanding. Maybe then we can communicate that kind of information with epidemiologists in order to determine if there is a safe level for those specific submicron particles. And when it comes to ultrafine particles, I agree that maybe particles per cubic centimeter is not the right tool, because in many cases, those instruments, they can also measure the size of the particles, so they can give you that Lang deposit surface area. So we can switch to that specific measure, but then it is difficult for some people, some folks out there to navigate with what WHO recommends, right? Like those specific particle per cubic meter that they have created. And for ultrafine specifically, I think we need more work. I think many people are working on that. Many researchers are working already in, unearthing more information around those particles. So we have to wait a little bit longer in order to determine if there is a specific range limit or something similar in order for us to recommend out there. Also, let's see what the next group is going to say at 7 p.m. Central European time. Maybe they have figured out some things and they will be able to share with them. So at the end, I'm going to combine everything, this call and the afternoon call, and share all this information publicly in order for you to review it as well. And potentially include some of this information inside the white paper. That's all. Thank you again. We did it on time, actually, which is great. I wish everyone a great day, afternoon, evening, or night, depending where you are. And thank you for your support and being here.
Thank you.
Thank you.
Thank you.
Thank you, Cecilia.
My pleasure. So let's stop recording.
Thank you, Sotiros. Bye-bye.
Thank you for being here. Bye.